So let's look at this question now. In how many ways can five books be arranged on a shelf if two particular books must always be together? So now from this question, we can already see that the question is talking about arrangement. So which means we are using permutation here. Right? It's not just that simple as the first one that we did, right? But this one now, they're telling us that two books must always be together. So if we go ahead and do five permutation two, we are going to get this wrong, right? But now let's understand. The question is telling us that there are five books, right? Okay, there are five books. So we have one, two, three, four. Now these are the five books. But now it's telling us that two must always be together. These two books here must always be together. So now let's take, for instance, let's say that these two books, let's make them to be equal to one book. This book here. So we have one, two. Now this last book is representing the two books. So if we decide to put this last book, decide to put it here, or we decide to put it anywhere in this arrangement, it is always going to tell us that that book that we are putting anywhere is representing these two books that are together. If we take them as one entity and then we find we solve it, then we are saying that we have put the two books together. Now because we put the two books together as one book, then we have four books. So we find in how many ways we can arrange four books. So automatically we are finding how many ways we are arranging five books that two are together. Because those two are together, we can just say they are one. Right? We can just say they are one. So now let's solve. Alright. Okay. Alright, so now in how many ways can five books be arranged on a shelf if two particular books must be? Now I already said there are four books. So how many ways can we arrange four books? So that is just four factorial, which is going, this is not bright enough. Okay, let me change the ink to black. Right, so we have four factorial, and four factorial is going to be 4 times 3 times 2 times 1, and this is going to be equal to 24. But this is not our final answer. Now this, now you know we arranged the four books, we arranged it 1, 2, 3, and the last one, let me use red so it can be a bit brighter, and the last one here. Now the issue is that these four books now, this last one represents two books. So we have to find the number of ways we can arrange those two books, because those two books, putting them together, anyone can be in. So let's say those two books are of different color. Let's say one is red, and let's say the second one is blue. So now this blue one can either be first or the red one is first. So it depends. So since we don't know how it is going to be, we have to find in how many ways we can arrange those two books among themselves. Right? That's just going to be 2 factorial. So that 2 factorial is 2 times 1, and we're going to multiply it with this 24 to get how many ways we can arrange 5 books in a shelf. Particular books must be together. So we're going to have 24 times 2, and this is going to be 48. So that means we can arrange those 5 books if 2 particular books must be together in 48 ways. In 48 ways. All right. So let's